And people would look to try to find transits of Vulcan and would see sunspots and get confused. They claim they found a planet. There's some people that died convinced they had discovered planet Vulcan.
No.
Have you ever wondered what it's like to discover a brand new world? In the last 3 decades, we've found over 5,000 planets outside our solar system, called exoplanets. I'm Dr. Jessie Christensen, the lead scientist at the NASA Exoplanet Archive. This is Explore Exoplanets, The Discoverers, a series where I interview the brilliant minds behind the discovery of brand new planets.
Welcome back, everyone. Just a reminder, if you're watching this on YouTube, you can also listen to it as a podcast. Head to Apple Podcasts or Google Play and take us with you on your morning commute. If you're listening to us, you can also watch us on YouTube, where you'll find some bonus graphics to help explain what my guests and I are talking about. And we are returning with Dr. Ben Montet, who is a Scientia Senior Lecturer at the University of New South Wales. Welcome back, Ben.
Thanks for having me. It's great to be here.
Hey, so we've just established that your favorite fictional planet is Vulcan from Star Trek. This is a classic science fiction planet. It's been around for 60 years now. I want to say thank you to all of the work that goes into the Memory Alpha fandom wiki for all of this information about Vulcan. Given that it's been around for 60 years, there's a lot of information. So we'll summarize. It's an inhabited M-class planet. It famously does not have a moon. Spock very specifically says no moon. But interestingly, it is a binary planet. There are 2 planets that orbit each other. The system has 4 planets in total, and the star, very cool, is an actual real star in the real sky, 40 Eridani A, which is in a triple system about 16 light years away. On the show, Vulcan, the planet, has a thinner atmosphere than Earth's and a higher temperature than Earth's. The atmosphere is shown as reddish. We don't really know what that means, but shown as reddish. So Ben, why is Vulcan your favorite?
Yeah, Vulcan's such a cool system. The Star Trek links, it's cool. Throughout, Spock is such an iconic character, and the whole it's so prevalent in Star Trek that it has lots of cool stories there. But also, there's really neat astronomy history around the name Vulcan, and also then the search for planets. That it's around a real star, right? In the Star Trek canon, it's around 40 Eridani, which is a system that people have observed for planets. But the name Vulcan comes from the history of 19th century planet searches in our solar system. One of the great breakthroughs in astronomy and celestial dynamics was the discovery of Neptune, where Uranus had some perturbation on its orbit. It wasn't quite where it's supposed to be, and some dynamicists worked out that this is because another planet is perturbing it and predicted right where it would be. And a couple different teams went out to try to observe it, and in the mid-19th century, basically found it right away. And so it's great, amazing prediction. It's how science is done. Right. The first planet discovered followed the scientific method, you could say. But then, famously, Mercury has this weird precession in its orbit as well, which we now know is general relativity. It's moving a little bit faster than it should be through its orbits. But this is pre-general relativity. And so at the same time, people said, well, Neptune was perturbing Uranus. This must be because of Mercury being perturbed by a planet inside of Mercury, which was given the name Vulcan. If you find old maps of the solar system, old atlases from that era, you can actually see parameterizations of there's a planet Vulcan. We haven't discovered it yet, but it's at this distance from the sun. We knew exactly where it was. People tried to find it. There were early observations of people looking.
It's hard to find things really close to the sun, right?
It's extremely hard.
Mercury's not easy to see. It's so close to the sun.
Yeah, and people would look to try to find transits of Vulcan and would see sunspots and get confused. They claimed they found a planet. There's some people that died convinced they had discovered planet Vulcan.
No.
In our solar system. And so there's such a history, and it really went all the way until Einstein's theory of general relativity, where we then understood where the precession of Mercury was coming from, that the idea of Vulcan as the perturber completely gets squashed. So it's so cool in the Star Trek universe, but also this cool homage to astronomy history.
Yeah, that is really cool.
Yeah.
All right, so I went into the NASA Exoplanet Archive. This one was kind of easy, actually, because it has a long history in the Exoplanet Archive. To find this week's counterpart of Vulcan, which is HD 26965b. And I'm sorry, the name is nonsense. Better known as 40 Eridani A B. And you'll recognize that name, as Ben said, 40 Eridani A is a real star in a real star system that people have actually looked for planets around. So my day job when I'm not hosting the podcast is I'm a scientist at the NASA Exoplanet Archive. And one of the things we do is put all of the newly discovered planets into the archive. Now, stars have been cataloged many times and have many different names. So when I was putting this planet in, I'm like, HD 26965b doesn't ring any bells. And I'm entering all of the aliases. It has a Hipparchus, it has a Tycho, it has all of these different names. And I get to 40 Eridani A, and I just type it in. And then I keep going. And there's like a little record scratch in the back of my brain. I'm like, 40 Eridani A, why do I know that? So this was 2018. In 2017, I had gone to my first Star Trek convention as a scientist who hunts exoplanets, and I had talked about how we were trying to find planets, and I had talked about how 40 Eridani A was a star that we were trying to find planets around. So in the back of my mind, I'm like, wait, is this the Star Trek planet? And I Google immediately, and I'm like, oh my God, we found it. We found a planet around 40 Eridani A. And I got very excited, and then the internet got very excited, which was a lot of fun. Sadly, unfortunately, 6 years later now in 2024, this planet has been refuted. HD 26965b is probably not real, or at least the version that was published in 2018. So this was a radial velocity discovery, like Ben was talking about in the previous episode, how you look for the star to wobble on the sky as the planet is tugging it around. Now, unfortunately, there are a bunch of other types of signals that happen on the surface of a star that can look like the star is coming towards you or going away from you, all sorts of stellar activity. And when these data were reanalyzed with that in mind, thinking about the stellar rotation, the stellar activity, it became clear that this signal of the planet that people had interpreted as Vulcan, we thought we'd found Vulcan. You can see why we were excited. It turns out it's probably stellar activity. So that is the roller coaster that is HD 26965b. We thought for a hot second we'd found Vulcan. Now that doesn't mean there isn't a planet like Vulcan around 40 Eridani A. The planet we had found was a sub-Neptune sized planet, so a bit smaller than Neptune, with a period of 42 days, so pretty hot because 40 Eridani A is a star like the sun, and this is closer than the orbit of Mercury. Truly very Vulcan-like, to be fair, if you think about the Vulcan in our solar system. But it's probably not there, which is kind of sad. Okay, so how is HD 26965b like Vulcan, the fictional planet? So they orbit the same star, or did before it was refuted. They're both hotter than Earth. Vulcan just a little bit hotter, HD 26965b much hotter. They're both small planets, although HD 26965b is not rocky. And I'm throwing this on just to be cheeky. Neither of them are real, right? They're both, turns out, fictional. One on purpose and one by accident. How is HD 26965b different from Vulcan? So it's a sub-Neptune. One of the things we discovered, Ben alluded to the fact last episode that Kepler found lots of planets that aren't like the planets in our solar system, right? And one of the most common kinds of planets we found are these sub-Neptune or super Earth-sized planets. So in between the small rocky planets of our solar system and the ice giants. We don't know what they are yet. So they're this intermediate size. We're not sure what the compositions are. Interestingly, they could be ocean worlds, getting back to the Kepler 10b joke from earlier about how it's an ocean world, but it's a magma ocean world. HD 26965b wasn't a binary planet. We haven't found any binary planets yet, but people are looking. And in fact, some of the exomoon candidates that we talked about when Dr. David Kipping was on the podcast probably would be more correctly characterized as binary planets because they're kind of like Neptune-sized moons going around Jupiter-sized planets. So you'd probably call that a binary planet if you were going to call anything a binary planet. And as far as we know, HD 26965 is not inhabited by Vulcans. So that's how they're different. But that's this week's Carbon Copy. A very, very exciting day in my life 6 years ago that turned into a very sad day in my life last year when it got refuted. Anything more you want to add about Vulcan, Ben?
That sounds great. I think you got the full story there. It's, it is a roller coaster, and we see these all the time. Right? There's a lot of radial velocity planets that have gone back and forth as to this is a planet, this is stellar activity, and it's a fun game, but it's a really hard problem that people work very, very carefully on.
Yes. All right. Speaking of the search for planets and how hard it is, are you still planet hunting?
Absolutely. So over here, my research group and I do a few different things. We do a lot of characterization, both on trying to better understand, looking at known planets. One of the things we look for right now is in spiral. So trying to find planets that are spiraling into their host star at the end of their lives. We do a lot of characterization of stellar activity and activity cycles, like the sun's 11-year cycle. We still do discovery as well. The thing I'm excited about right now is looking at circumbinary planets. So flipping from Star Trek to Star Wars, the planets like Tatooine that have two stars going around with a planet going around both of them.
Right. All right. Is there any particular instrument or telescope you're using for this?
Yeah, we're using the TESS telescope. This is NASA's new Planet Hunter. It's not that new now. It's been around for 5 years. But it's the successor to Kepler, kind of similar methods, but all sky. And so TESS with a suite of ground-based facilities, including the VLT in Chile. This is a very large telescope. Astronomers are not amazing at naming things always.
Really not great.
No. And the AAT, the Anglo-Australian telescope up in Coonabarabran, Australia, just a few hours away from me.
I also spent a lot of time at Coonabarabran. The beach in Coonabarabran, that was my whole PhD at the University of New South Wales.
You could do a lot worse.
Yeah, it was rough. All right, it's time to answer a question from the audience. We're so glad that you're all listening and curious about exoplanets. So one question we've got that we wanted to answer is, are most of the discovered exoplanets like the planets of our solar system, or are they very different? Now, we've actually touched on that a couple of times, last episode and this episode with Dr. Montet. But Ben, do you want to tell us a little bit more about what we found and how it's different from our solar system?
Yeah, absolutely. So there's kind of two different ways to answer this, which we can talk about the planet specifically. And there are a lot of planets that we've discovered that are quite similar in terms of being planets, right? Planets that are like Jupiter, roughly the size of Jupiter, the mass of Jupiter. We've discovered a lot of those, but they're in very different places. It's not as common. Not all stars have a Jupiter, meaning this size planet at 5 AU. We've discovered a lot of these very close to their host star. We call them hot Jupiters. They're not intrinsically that common, but they're easy to find. So we have discovered hundreds of them. So planet like Jupiter, but in a 3-day period around its star. We've discovered lots of small Earth-sized planets, but again, we haven't found the one that's Earth-sized at 1 AU from a sun-like star, with evidence for water on its surface and all the other things that we love here having on Earth. So in terms of when we look holistically at systems, I would say, we haven't found any real true solar system analogs. Nice, small planets in short periods, giant planets in wider orbits, with everything that we have.
Yeah, and the only thing I'll add to that is we haven't refuted that those kinds of systems exist. They're just largely beyond our sensitivity right now. There might be lots of analogs of our solar system. It might not be that we're rare or different. It's just that we're hard to find. So yeah, we're still looking. We're hoping to find Earth 2.0 and Solar System 2.0 at some point, but unfortunately not quite yet. Thank you, Ben, and thank you everyone for joining us. If you want more out of this world astronomy content, please join us for our next episode and like and subscribe to explore exoplanets. You can follow us on Instagram, Facebook, and X, where you can send us your burning questions about exoplanets, real or fictional, and beyond, for us to tackle in an upcoming episode. Thanks, everyone. Bye.